Somewhere in the early universe, less than 1 billion years after the Big Bang, there is a category of object that astronomers have started calling, without much exaggeration, a black hole star. It looks, at first glance, like an ordinary, if unusually compact and strangely red, young galaxy. It is not. Hidden inside that glowing red cocoon of gas is a supermassive black hole growing in the dark, consuming its own birth cloud from the inside out, gradually burning holes through the very material that first gave it shape. When astronomers finally captured direct, detailed evidence confirming exactly what these objects actually are, the discovery did not simply solve a genuine years-old mystery. It confirmed something a considerable number of scientists studying this exact question had quietly hoped would. Turned out not to be true, because if this specific interpretation holds, it means the early universe built its first monsters faster, and in a considerably stranger way, than anyone had seriously prepared for. This is the real story of the little red dots, why they earned their unsettling nickname, and why the evidence confirming what they actually are has left astronomers with a genuinely uncomfortable new picture of how the very first supermassive black holes actually came into existence. It is worth being upfront about why a story like this deserves to be taken seriously rather than dismissed as manufactured drama, because the phrase, "something scientists wish wasn't real," can easily sound like the kind of exaggerated framing this exact series has spent considerable time correcting in other videos. This one is different, and the difference matters. Nobody involved in this research is claiming evidence of anything supernatural, anything artificial, or anything violating the basic laws of physics. What they are describing, in their own carefully worded, peer-reviewed publications, is a genuine, confirmed departure from decades of established theory about how the universe's first supermassive black holes actually grew, a departure serious enough that some of the very researchers who helped confirm it have been remarkably candid, in interviews and public talks, about having hoped the data would eventually point somewhere else. To understand why this discovery unsettled so many astronomers, you first need to understand exactly how strange these objects looked from the very beginning. When the James Webb Space Telescope began returning its first deep field observations of the early universe in the summer of 2022, astronomers led by Ivo Labbé at Swinburne University of Technology in Australia noticed something nobody had specifically been looking for: 13 small, unusually bright, strikingly red points of light scattered throughout the deepest images the telescope had captured. When Labbé's team estimated the mass and distance of these objects based on their brightness and color, the results were immediately deeply puzzling. Several of them appeared to carry a mass nearly comparable to our own Milky Way galaxy, despite existing within the universe's first 600 to 700 million years. A time frame existing models generally agreed was far too brief for any galaxy to have accumulated that much mass through ordinary, gradual star formation. These objects quickly earned an informal nickname reflecting their most obvious visual characteristic: little red dots, and they turned out to be everywhere. Practically anywhere. Webb looked deep enough into the early universe, they appeared compact, red, and strange. Before then, mysteriously, almost entirely vanishing from view, once the universe reached roughly 2 billion years of age, as though an entire population of objects that had once filled the early cosmos had simply stopped existing, or transformed into something else entirely. What made this initial discovery so genuinely disorienting for the astronomers involved was how completely it defied their own expectations going into the mission. Webb had been built, in considerable part, specifically to find and study the earliest galaxies in cosmic history, and researchers expected those galaxies to look small, faint, and irregular, exactly the kind of young, still, assembling structures that decades of theoretical modeling had predicted should dominate the universe's first several hundred million years. Little red dots did not fit that expectation at all. They were compact, remarkably bright, for their apparent distance and consistently distinctively red in a way that demanded an explanation. Compounding the confusion later, more detailed spectroscopic study of these objects, including a widely discussed analysis led by Harvard astronomer Anna de Graaf, identified water vapor within several little red dots, a finding that helped establish just how comparatively cool these objects actually are, with temperatures generally falling somewhere between about 1700 and 3700 degrees Celsius. That range sounds extreme by any everyday standard, but it is considerably cooler than the surface of our own sun, and cooler still than the blistering temperatures typically expected from actively feeding supermassive black holes in the modern, nearby universe, adding yet another layer of genuine puzzle to an already strange population of objects. For the following several years, astronomers debated several competing explanations for what these objects actually were. One possibility suggested they were extraordinarily dense, extraordinarily compact galaxies, containing an almost impossible concentration of stars packed into an extremely small volume of space, potentially, if this interpretation held, representing the single densest stellar systems ever observed anywhere in the universe. A second competing possibility suggested they instead hosted actively growing supermassive black holes at their centers, with their glow produced by gas becoming superheated as it spiraled inward toward the black hole's own immense gravity, the same basic mechanism responsible for the light produced by active galactic nuclei and quasars observed throughout the more thoroughly studied nearby universe. Both explanations, though, carried a serious, persistent problem. Both proposed objects seemed, in either case, too massive to have plausibly formed this early in cosmic history, using any conventional, well-understood formation process. And in the specific case of the black hole explanation, there was an additional, glaring inconsistency. Actively growing supermassive black holes should reliably emit detectable X-rays and radio waves as surrounding material heats up and falls inward. And for years, astronomers searching the little red dots for exactly this kind of signature consistently came up empty, finding neither. This absence of X-ray and radio emission was not a minor technical footnote. It was, for a considerable stretch of time, the single strongest piece of evidence working against the black hole interpretation entirely. Researchers pointed out that if little red dots genuinely hosted actively feeding supermassive black holes on the scale their brightness seemed to imply, standard physics predicted those black holes should be shining brightly in X-ray wavelengths, exactly the kind of signal astronomers already knew how to detect reliably in more conventional nearby quasars. Repeated, dedicated searches using the world's most sensitive X-ray observatories turned up essentially nothing, a stubborn, persistent silence that left the black hole hypothesis looking genuinely troubled. For years, even as the alternative explanation, impossibly dense star clusters carried its own equally serious theoretical problems. This is where the specific, more unsettling hypothesis began to take shape, an idea researchers eventually named black hole stars. Under this model, a little red dot is not simply a black hole quietly sitting at the center of a normal galaxy, gradually accumulating mass the way supermassive black holes in the modern, nearby universe generally do. It is instead an actively growing black hole almost entirely enshrouded by an extremely thick, extremely dense cocoon of surrounding gas. A cocoon so dense that it physically absorbs and reprocesses nearly all of the X-rays the growing black hole would otherwise be emitting, converting that high energy radiation into the softer, redder glow Webb's instruments actually detect, while simultaneously explaining why traditional X-ray searches had failed to find any direct evidence of a black hole hiding inside. In this model, the black hole is not living peacefully within its host structure. It is actively, continuously consuming it, feeding on the surrounding gas cocoon from the inside out, growing steadily larger and more energetic as it does so. Confirming this specific, unsettling interpretation required considerably more detailed evidence than simply observing a little red dot's general color and brightness. And that confirmation finally arrived through a combination of studies published across the first half of 2026. In April of 2026, researchers examining a specific little red dot called 3DHST Aegis 2014 detected something genuinely significant. Scattered X-ray emission finally breaking through, visible for the first time, interpreted by the research team as direct evidence of the central black hole actively carving physical holes through its own surrounding gas cocoon, exactly the kind of gradual, violent self-consumption the black hole star model had specifically predicted. Then, in June of 2026, a research team led by Vasily Kokorev at the University of Texas at Austin obtained what NASA's own official announcement described as the deepest spectrum ever captured of a little red dot, examining an object called GLIMPS 7975, magnified and made visible only through the gravitational lensing effect of a massive foreground galaxy cluster called Abell S263, bending and amplifying its otherwise undetectable light. Kokorev's team identified more than 40 distinct spectral lines within that single, extraordinarily detailed observation, a genuinely comprehensive chemical and physical fingerprint, and the research team reported that this specific combination of evidence, taken together, independently and consistently supported the same underlying interpretation, that GLIMPS 7775 is indeed a supermassive black hole enshrouded by precisely the kind of hot, dense gas cocoon the black hole star model had proposed. Researchers studying these objects have described the significance of this confirmation in genuinely striking terms. One line of analysis noted plainly that if little red dots really are black hole stars, they would represent a crucial missing link in understanding how the earliest, most massive black holes in the universe's history actually managed to form and grow so quickly, connecting directly to a separate, related mystery that has emerged from Webb's observations, the discovery of individual black holes that appear to have formed before and disproportionately larger than the galaxies eventually found surrounding them, directly inverting the sequence of galaxy and black hole formation. Astronomers had assumed applied universally across cosmic history. Here is precisely why a considerable number of scientists studying this exact question have been genuinely candid about hoping this specific interpretation might somehow turn out to be wrong, rather than simply treating the confirmation as an unambiguous scientific triumph. If black hole stars genuinely represent a real, common evolutionary stage that supermassive black holes pass through during the universe's earliest years, it means these objects achieved an almost incomprehensible growth rate, accumulating hundreds of thousands to potentially millions of times the mass of our own sun within a genuinely brief cosmic window, considerably faster than any conventional model of black hole growth built from decades of study within the relatively nearby, well-understood modern universe had ever confidently predicted was physically possible. It suggests the standard picture of a gradual, patient black hole growth, accumulating mass slowly over billions of years through ordinary accretion and occasional mergers, may simply not apply at all during the universe's earliest, most chaotic period, replaced instead by a genuinely more violent, more rapid process that current physics does not yet fully explain. Astronomers studying the population statistics of little red dots have identified an additional, genuinely puzzling wrinkle, reinforcing the same discomfort. These objects appear in significant numbers extremely early in cosmic history, and then their numbers drop off a cliff at a specific point, roughly 2 billion years after the Big Bang, essentially disappearing from Webb's view entirely. Researchers have proposed exactly two possible explanations for this sudden disappearance. Either the entire population of black hole stars simply died off during this specific window, their rapid, violent growth phase burning through the available surrounding material and effectively extinguishing itself, or, in the second, currently favored possibility, they gradually evolved into something more familiar, transitioning into the more conventional active supermassive black holes and quasars astronomers already recognize and understand within the more mature, considerably better studied universe. Either explanation still leaves a genuinely significant, unresolved question about exactly what specific physical process drives that transition and why it appears to happen within such a comparatively narrow, specific window of cosmic time. It is worth being honest and precise about exactly what remains scientifically uncertain here, since that precision is exactly what separates a genuinely significant, still evolving scientific picture from an overstated, fully settled conclusion. The evidence supporting the black hole star interpretation has grown considerably stronger across 2026, moving from an initially speculative hypothesis to a position now backed by multiple independent lines of spectroscopic and X-ray evidence. But researchers have been careful to note that not every little red dot has yet displayed the same complete combination of confirming evidence simultaneously, and the broader population likely includes some genuine diversity, potentially a mixture of black hole stars, alongside other still not fully understood categories of object, rather than every single little red dot necessarily representing an identical underlying phenomenon. It is also worth stepping back to appreciate why this specific finding genuinely qualifies as something scientists might reasonably wish had turned out differently, beyond simply representing an unusual or exotic astronomical curiosity. Modern cosmology rests on a carefully constructed, extensively tested framework describing how galaxies, stars, and the supermassive black holes found at their centers all form and grow together over cosmic time, a framework built from decades of patient observation of the relatively nearby, well-studied universe. Black hole stars, if this interpretation continues to hold under further scrutiny, represent direct physical evidence that this framework, however successful it has been at explaining the universe we can observe in detail nearby, may be fundamentally incomplete when applied to the universe's earliest, most extreme conditions, a genuinely uncomfortable position for any well-established scientific framework to find itself in, no matter how many other aspects of that same framework continue to be confirmed correct. That discomfort, though, is precisely what makes this exactly the kind of discovery legitimate science is supposed to produce. Nobody studying the little red dots set out specifically hoping to find evidence contradicting existing models of black hole formation. Ivo Labé's original team was simply cataloging distant galaxies when these strange red objects first appeared, unexpected and unexplained in their data. The subsequent years of careful, methodical investigation, testing competing hypotheses, searching for X-ray evidence, eventually capturing a sufficiently detailed spectrum to properly settle the question, represents exactly how genuine scientific understanding is supposed to progress, even when, and especially when, the evidence eventually points toward a conclusion the researchers involved might have personally preferred to avoid. So here's the honest, complete picture behind what James Webb has genuinely found, and why it remains something more than a few astronomers have been candid about wishing wasn't quite so definitively confirmed. The little red dots scattered throughout the universe's first 2 billion years increasingly appear to be black hole stars, supermassive black holes actively, consuming their own dense surrounding gas cocoons from the inside out, growing at a pace that challenges decades of established theory about how black holes are supposed to form and evolve. The evidence supporting this interpretation, gathered through independent X-ray detections and an extraordinarily detailed spectroscopic analysis published just this year, has grown considerably stronger throughout 2026, even as the underlying implications remain genuinely uncomfortable for a field that had, until Webb's arrival, built a coherent, well-tested picture of black hole growth that this new evidence now suggests may simply not apply to the universe's earliest, strangest chapter. If you want to see what Webb reveals next as astronomers continue tracking exactly how these black hole stars eventually evolve into the more familiar objects we observe throughout the rest of cosmic history, subscribe and turn on notifications, because this mystery is still actively unfolding, and the next piece of evidence could reshape this picture yet again.